Okay, hi grade 10. So today we're going to talk about the different types of chemical reactions. So the first thing we need to remember is that chemical reactions illustrate what is made, or what we call the products, when certain ingredients or reactants are combined. That's just in general what is made when certain reactants are combined. So we can just kind of generally say that reactants give products in a chemical reaction. Okay, all chemical reactions involve the release or absorption of energy, and this can be done in a bunch of different ways. So it could be light, it can be electricity, it can be sound, but most often what we're talking about here is thermal energy. So thermal energy is just another way of saying heat. So heat energy normally is what we're talking about. Certain chemical reactions can be classified, all chemical reactions can be classified according to their nature. So there are chemical reactions that absorb heat. These are called endothermic reactions. And there are chemical reactions that release heat, and those are exothermic reactions. So endothermic are more rare. They're actually quite rare compared to exothermic reactions. Most reactions are exothermic, but some can be endothermic. And those are still true classifications. So we can still classify a reaction as being endothermic or exothermic, but we also have this additional set of classification, or additional set of criteria, if you will, to help us understand different chemical reactions a little bit better. Because just the distinction between endothermic and exothermic is not quite precise enough for our liking. So instead we have sort of these 5 overarching categories that we talk about in grade 10 of different chemical reactions. So the first one is called a synthesis reaction. So synthesis reactions are classified as reactions where 2 or more substances, and normally here we're talking about elements. So 2 or more elements combine to form a new, more complex substance. And the general format for this is going to be A plus B gives AB. Okay, so here on the side you have Na and Cl. So Na and Cl combine to make NaCl. That's a synthesis reaction. And then on the bottom of your note page here, you have just a little bit of practice balancing your equations, just in case you didn't have enough already. And these are 2 separate examples here. Okay. Our second type of reaction, and so again, just as a reminder or as a little side note, you should be able to predict what products you're going to get based on the reactants that you have and the different types of reactions that you know. So you know that if you have 2 elements that they will combine to make another new compound in the case of the synthesis reaction. Okay, another type of reaction that we learn about is called decomposition. Okay, so a compound decomposes into its essential elements. Okay, or compounds in some cases. And this is essentially just the opposite of synthesis reactions. Generally, this kind of reaction is endothermic, which means that it will absorb heat. Okay, because, and that's just because energy is needed to break the chemical bonds of most compounds. So when we're decomposing something, we're actually breaking the bonds between different parts of a compound, and that is why you have an endothermic reaction. So the general format for this is AB gives A plus B. A little example here from your real life is that the airbags in your car actually work using decomposition reactions. So you have energy and Na3, which decompose to give you just sodium and nitrogen gas. Okay, our third type of reaction is called simple replacement, or sometimes you will hear simple displacement. Okay, so in simple displacement, you have an element or a compound that is replaced by another element or compound. So for example, and in this case, when you have this kind of simple displacement, you're just going to have metal replacing metal and non-metals replacing non-metals. So here you have a metallic element will only replace another metal, and a non-metal will only replace a non-metal. And again, if we talk about kind of the basic structure of this, it's going to be A plus BC gives AC plus B. So if you look at the side example here, you have zinc and hydrochloric acid. They come together and they will, the zinc will replace the hydrogen in this case. So the hydrogen is acting as a metal. So it will replace the hydrogen and form zinc chloride and hydrogen gas. And you have some more examples there as well in your notes. Okay, the next type of reaction is called a double replacement. Oops, excuse me. Double replacement or double displacement. Elements in different compounds replace one another. So you kind of have sort of this double switcheroo happening. So again, this is the general form. So you have AB plus CD gives AD plus BC. This usually occurs in aqueous solution. So typically you are going to have some maybe ionic salts dissolved into aqueous solution. You're going to mix them together and you get this double displacement reaction happening. So often what happens in the case of double displacement reactions is that you have precipitates that are formed because not all ionic compounds are soluble in water. Many are, but they are not all soluble in the solution in water. So what happens is you end up with a precipitate that kind of leaves the substance and forms in the solution. It will often fall to the bottom of the solution, but this is kind of the idea. Okay, and finally, combustion. So combustion is interesting because it's kind of a different, it's a little bit different than the other ones that we've been talking about. So in combustion reactions, what you have is a rapid reaction of a substance with oxygen. So that's what happens when you combust something, is you actually have this reaction with oxygen. And this reaction with oxygen produces something called oxides. So you'll always end up with some sort of oxide in a combustion reaction. The reaction releases energy, so it's exothermic. And here is the general formula. It's not quite, this is the general formula, it is accurate. It's just that we have two very distinct situations with combustion that we're going to talk about in a second, and they kind of have their own sort of general format that we'll go over. Another thing that I just want to mention is that if you look at the picture here, so you have some Bunsen burners and you have one that has an orange flame and the other one that has a blue flame. So notice how the blue flamed image has lots of air coming in through the bottom of the Bunsen burner. This is what happens when we have something called complete combustion. We have a lot of oxygen, everything is going great, we end up with this blue flame. The orange flame, you have less oxygen coming in, and that causes something called incomplete combustion. Okay, and that's because we just don't have enough oxygen required to really do the reaction well. And we'll talk about the different types of complete and incomplete combustion in just a second. So typically, combustion uses some kind of fuel, and this fuel is often hydrocarbons. So hydrocarbons are just hydrogen and carbon mixed together in some amount. So that's why you have sort of CXHY, is it just there is some combination of these two things. So for example, your example here uses methane gas. So methane is CH4. Are the examples in the boxes that are coming are going to use butane, which you'll see in just a second. But it'll be just some kind of hydrocarbon. Fossil fuels are hydrocarbons, natural gas, which is a fossil fuel, but natural gas is a hydrocarbon. Most of the fuel that you're used to using is a hydrocarbon. So again, coming back to this idea of complete and incomplete combustion. So complete combustion occurs when there's a lot of oxygen to be burned. So we have all the oxygen we need in order to burn really well. The products of complete combustion are water and CO2. So if we take a look at what the chemical formula, for example, for the combustion of butane is, you have butane, which is CH4, C4H10, sorry. You have oxygen, which combines to make CO2 and water. Now, of course, this is not a balanced equation, so we're just going to balance it out. But here you can just see that, we have these individual reactants and products. So we have our butane. We actually need 2 of those. We have our oxygen. We're going to have 13 oxygen, which is a little bit crazy. 8 and 10. Okay, so this is the reaction for complete combustion. Now, incomplete combustion, remember, occurs when there is not enough oxygen. So it occurs in the absence of sufficient oxygen. So it's just not as good of a combustion. It's just not as good of a burn. The products of incomplete combustion are soot. Soot is essentially carbon. Okay, that's why it's kind of black, because carbon itself is black, and so it's this black sort of ick that gets thrown into the air, and it also creates carbon monoxide, which we all know because we have carbon monoxide in our homes. That it's just not. It's not good for people. Okay, it's not a good. It's not something that we want to be spewing into the air from our incomplete combustions. So if we take a look at the chemical formula for this reaction, okay, so same thing, we're using butane. Okay, we end up with C4H10 plus oxygen, and in this case we only have 5 oxygen, which, as you notice, is a lot fewer than 13. We're going to have 2 CO2 plus 5 water plus CO, carbon monoxide, plus carbon. So these 2 final examples here, these 2 final products, that is what is kind of the issue with incomplete combustion. It's these 2 guys right here, the carbon monoxide and the soot. We don't really want those as products. We would much rather have carbon dioxide. So that is incomplete and complete combustion. So again, remember, the blue flame indicates complete combustion. It indicates that you're using as much oxygen as you need. You're making CO2 and water. Incomplete combustion, and it's also hotter. So complete combustion is actually a lot hotter, whereas that kind of beautiful orange flame that everybody likes is actually less effective. It's not as hot. So and then incomplete combustion is that orange flame. You get carbon monoxide and soot created as products in addition to your CO2 and water. That's all for our types of reactions. You should be able to predict the products from the different types of reactions. So if you see different reactants, you should be able to identify the type of reaction. And then by identifying the type of reaction, you should be able to also predict the product. Is it going to be, a synthesis reaction where you have the 2 elements coming together? Are you going to be decomposing? Is there going to be a switch of one element into a compound when another one is taken out? Or are you going to do a switch of, a metal with a metal and a non-metal with a non-metal in the sort of double displacement vein? So those are things that you should know after having done all of the work learning the stuff in this note. Again, if you have any questions, please feel free to ask.